My last video, I talked about the determinant, the adjoint, and the inverse of a 2 by 2 matrix, and I also explained on how to use the inverse to solve a pair of simultaneous equations. We are going to apply the same in solving this question. First of all, let's pick the coefficients of I1 and I2 and write them in matrix form. So the pair of the simultaneous equations, you are going to rewrite them in matrix form. And this is what we have. Shall have 2, 5, 3, negative 2 in matrix form. This one multiplied by I1, I2, and then equals to 13, 14. Okay, next step is we are going to get the determinant, which is given by you take 2 times negative 2 and then subtract 3 times 5, and that is negative 4 minus 15, which is negative 19. And then I go ahead and get the adjoint of A, whereby the leading diagonal elements, they are going to interchange. So negative 2 comes here and 2 comes there. And then the other diagonal elements, the signs are going to change. So if here 3 was positive, it becomes negative. Here 5 was positive, it becomes negative 5. So that is our adjoint, and therefore inverse as usual, you take the adjoint and divide by the determinant, which is the adjoint matrix is negative 2, negative 5, negative 3, 2, divide by the determinant, which was negative 19. Now we are going to multiply both sides of the equal by the inverse, and that is, you are going to take the inverse here, multiply on this left hand side, and then multiply the right hand side of the equal. So the adjoint over the determinant here, the adjoint matrix divided by the determinant, can also be written as, or in other words, you can come and write the inverse as negative 1 over 19 into negative 2, negative 5, negative 3, and 2, of which from here you can go ahead and simplify, but you will still get the values. So this one will just be the same as negative 2, negative 1 over 19 times negative 2, which is a scalar multiplication, is just the same as 2 over 19, and that one will be 3 over 19, 5 over 19, and this one will be negative 2 over 19. But I prefer to leave it at that point. We shall simplify as we go by. Okay. So taking the inverse, multiply on my left hand side, that is negative 1 over 19 into minus 2, minus 5, minus 3, and 2, multiply by 2, 5, 3, negative 2, multiplied by I1, I2, equals again the inverse, negative 1 over 19 into negative 2, negative 5, negative 3, 2, multiplied by 13, 14. Okay, let's start by multiplying these two. So we shall have negative 2 times 2, that will be negative 4 plus negative 3 times 5, which is negative 15. Okay, negative 5 by 2, that is negative 10, plus 2 times 5, which is 10. And then we proceed now, negative 2 times 3, that is negative 6, and then add negative 3 times negative 2, which is positive 6. Finally, negative 5 times 3 is negative 15, and then add 2 times negative 2, which is negative 4. And negative 1 over 19, don't forget, that one is outside. This one multiplied by I1, I2 equals negative 1 over 19 into, let's multiply again on this side, these two matrices. Negative 2 times 13, that is negative 26, add 2. Negative 3 times 14, which is negative 42. Negative 5 times 13 again, which is negative, that is negative 65. And then add to 2 times 14, which is 28. Okay. On my left hand side, this is what I have, negative 1 over 19 into, okay, negative 4 plus negative 15, that is negative 19. Here I shall have a 0. Here also I shall have a 0, and this one is again negative 19 multiplied by I1, I2 equals negative 1 over 19 into negative 26 plus negative 42, that will give us a total of negative 68, and this one becomes negative 37 from my calculator. Okay, simplifying this one here, there's scalar multiplication here. You take negative 1 over 19 times negative 19, you get 1. Multiply by 0 gets 0, multiply by 0 you get 0, and then multiply by negative 19 you get 1. And here we have what is called an identity matrix, from which if you multiply by I1, I2, the result will be I1, I2. Okay, let's simplify my right hand side of the equal, so I shall have a negative 19 times negative 68, and that is the same as 68 over 19, because a negative times a negative is a positive, and then here I shall have 37 over 19. Alright, now I said the identity matrix multiply by I1, I2, you will still get I1, I2. And multiplying an identity matrix by another matrix is the same as multiplying by 1. And this one is the same as 68 over 19, and this one is 37 over 19. From which I1, you just equate the corresponding elements. So I1 will be 68 over 19, and I2 will be 37 over 19. Yeah, so this is how we go about solving such a question. And of course, you can divide 68 over 19 is approximately equal to 3.58. You can simplify up to that point, and then I2 is also approximately equal to 1.95. Thank you for watching. Until next time, bye for now.